Welcome guys. Um, Today we'll be adding and subtracting bases, right? We'll be having addition and subtraction of our bases. Now I give you two unique questions wherein we'll be adding, and in the next one we'll be what subtracting. So that'll keep the ball rolling as we solve this particular problem. Okay, to solve this base problem, firstly you observe the two bases have to be the what same. You have to make the same basis the same. If you notice that the two bases the same, the question is very easy. But if you notice that the two bases are not the same, note you have to make it the same, right? Okay, so let's go about solving this problem. We're saying that let's say 1 1 0 0 1, right? Then we have 1 0 1 1 1, and we say this is what base 2, right? Base 2, right? All right. Now when in this form, now this addition, right? We add them. Now the rules here say you shouldn't exceed the base, right? Say the rules for adding and subtracting in other numbers bases are exactly the same as for decimal numerator, right? So we say all what you have to do, I would say, is to remember that the base is not base 10, right? For example, when working in base 2, you borrow 2 and not 10, right? Since we're working with base 2, when we are about to borrow, you borrow 2, we will not borrow 10, right? Okay, now we're standing, we can solve this problem. Now, we know that when add 1 plus 1, we will have 2, and we don't want to be, your base shouldn't be equal, and it shouldn't be more, right? When your base is equal, you have to divide by that base, right? So since we add 1 plus 1 again over 2, right? So just saying the base 2 divided by what? The same 2, right? This 2 divided by the base, right? Okay. So we say 2 going to itself 1 time, 2 times 1, 2, right? We will subtract, here will be 0. Now we are interested in the remainder, right? So the remainder here is what? 0. So we put our 0. But note we have 1 here as the quotient, right? Now we bring this one here. So we say 0 plus 1 is 1 plus this one is 2. Now if we do our same calculation, we're going to have the same denominator again, right? Here will be 0 and we'll carry our 1. The same way, 0 plus 1 is 1 plus this one is 2. And we know that we'll do our same calculation, we're going to get 0 here and we'll carry the 1, right? Then we say 1 plus 0 is 1 plus this one is 2, right? When we do our calculation, we know that we also have 0, right? Also have 0. Now, if we come here, we still carry the 1. If we come here, we say 1 plus 1 is 2 plus this one is what? 3, right? 1 plus 1 is 2 plus the one that we carry is what? 3, right? So it's the same 2 divided by what? 3, right? So we say 2 going to 3, 1 times 2 times 1, 2, and we'll subtract, we're going to get 1. So we're interested in the denominator, in the remainder. So we're going to take the remainder 1. Now the quotient is less than 2, so we'll take the quotient to be 1, right? Now this is your answer for this particular problem. Very cheap and easy. The reason why we are now going about to divide this, because it's the same thing repeating, the repeating of the same form. So we don't have to go say 2 divided by 2, 2 divided by 2. Right? We just use this one out here to solve all of them until we reach here to 1 plus 1 plus this one will carry a 3, and then we solve this problem, right? So this is your answer for this question. Now let's solve the last question. And the last question says, evaluate 2 full, 2 3 full base 5 minus 4 1 full base 5, right? Now we also observe that this particular question is the bases are the same, right? Since we know that the bases are the same, it make it very easy for us to solve now, right? So we say 2 3 5, and we get 1 4 1. So we do subtraction, say this, then we do a base 5, right? So we can solve this problem fine, right? Now we know very well that when we add this, will be above the base, right? We don't want to get equivalent to the base or above the base. We want to get below the base. So if we add this 1 plus, I would say 1 plus 5, definitely, sorry, it's not add but subtract. Thank you very much. It's not adding but subtracting, right? We know very well that when we subtract 1 from 5, we get off 4, and 4 is less than the base, right? So we put 4 here, right? We put 4. Now we have here, we cannot take 4 from in 3, right? Since we cannot take 4 from in 3, we're going to borrow from this 2. And when you're borrowing from this 2, it is 1 in your head, right? But you are borrowing 5, right? So if you take 1 from here, you're going to add it to this 3, but your borrowing should be in base 5, right? So it's just the same of 5 plus 3, right? Which will be what? 8, right? So it's just the same 5 plus 3 should be 8, right? Here will be 8. So we'll take out 4. We'll take out, let's say, we'll take out 4 from in 8. We'll have 4. Okay. From the problem, here should have been 5, right? Okay. And I put, instead of me putting 5, 4 here, and I place 5 here. But it doesn't matter, right? We can just change this to 5, right? It's the same concept, right? Just change it to 5, and we kick the ball rolling, right? It's the same thing. So we'll subtract 1 from here. We'll subtract 4 from in this 8, we get 4. Now we left with nothing here but 1, right? We left with 1. So 1 from in 1 is 0. So our answer for this will just be 44 base 5, right? The only thing that we did, instead of putting 4, we put 5, right? So definitely we'll use 5, right? When we use 5, we'll solve this problem, right? So thank you guys. Any question, please put it in the comment section below. Like, subscribe, and tap on the notification bell for any upcoming video. Thank you for your time and patience.